Hello students and welcome back to Short of Sir classes. This is the 10th video on graphs and we'll be dealing with inverse trigonometric functions. So let's get started. Here's the graph of sine inverse x. Now note that one sine inverse x is an odd function, hence it is symmetric about the origin. Number 2, it is defined for y belongs to, for all y belongs to minus pi by 2 to pi by 2 and mod x is less than or equal to 1, which implies minus 1 x1, that is x belongs to minus 1 comma 1. Right, so this is the origin and you will see that this graph is symmetric about the origin. So how do we know that sine inverse x or tan inverse x is an odd function? We'll use something called Maclaurin's series. It's beyond the scope of this video, but I'm just saying that you can use Maclaurin's series to find what is sine inverse x, and hence you can say that sine inverse x or cos or tan inverse x is an odd function. Alright, so let's move on to cos inverse x. Now cos inverse x is an even function. Cos inverse x is an even function, which means that cos inverse x is actually symmetric about the y-axis. You can see it clearly here. So let's just write it here, that cos inverse x is an even function and you can just keep it short and simple, even function, hence it is symmetric about the y-axis. Alright, now the domain and range. Cos inverse x is defined for all y belonging to 0 to pi and mod of x is less than or equal to 1, which implies that minus 1 less than or equal to x is equal to 1, that is x belongs to minus 1 comma 1. Moving on, we'll move on to tan inverse x. Now here's the graph of tan inverse x. So as you can see, it's symmetric about the origin, which implies that this is an odd function. Alright, let's so write that down. 1. Tan inverse x is an odd function and hence it is symmetric about the origin. Alright, so the next point should be about the domain and range of tan inverse x. So we'll write that it is defined for all y belongs to minus pi by 2 to pi by 2, hence and x belongs to R. Since tan y equals to x and x can be any real number, we have x belongs to the set of reals. So we'll do cot inverse x, cosec inverse x and sec inverse x in the next video. Thank you for watching.